So in a previous video, I introduced the change of base rule for logarithms, which states log base a of b equals log base c of b over log base c of a, where c is any valid base. This is useful for rewriting any logarithm in terms of logarithms of any other base. A special case of this is the change of base rule for common logarithms, or logarithms of base 10, which states log base a of b equals log of b over log of a. This is useful for rewriting logarithms in terms of another base when you don't really care about which base you rewrite it in, and you just want the convenience of writing common logarithms, since they're shorter to write, and log base 10 of a is just written in shorthand as log of a. Yeah, that's really the reason we use common logarithms so much when doing the change of base rule. I would like to introduce another special case of the change of base rule, and I'll call it the reciprocal rule for the change of base rule, or just the reciprocal rule for short. This is because I already called another property of logarithms the reciprocal rule as well in a previous video. Honestly, this isn't like calculus where every rule for differentiation has an official name. Most of the rules for logarithms don't have official names, so I'm just calling them what I commonly see them called. So just to be clear, I'm calling the property I am introducing the reciprocal rule from now on. I also say it's another special case of the change of base rule because the change of base rule for common logarithms is also a special case in itself. So the reciprocal rule is log base a of b equals 1 over log base b of a, where you can switch the base and the argument, or the top part, in a logarithm if you put the logarithm in the denominator. This is useful for simplifying some expressions, and it can also be proved using the more general change of base rule. So here's a quick proof. If we start with log base a of b and use the change of base rule, we can rewrite this as log of b over log of a. If we divide both the numerator and denominator of this fraction by log of b, we end up with 1 in the numerator and log of a over log of b in the denominator. That's how we get this complex fraction. And if we use the change of base rule again, log of a over log of b is just log base b of a. So the entire expression is just equal to 1 over log base b of a. So log base a of b equals 1 over log base b of a. So here's a full example using the reciprocal rule. If we have 1 over log base 4 of 20 plus 1 over log base 5 of 20, you'll notice that the two logarithms have different bases, but they have the same argument of 20. And the argument is the top part of the logarithm. And this makes the expression simplify nicely if we use the reciprocal rule on both fractions. So let's just write 1 over log base 4 of 20 as log base 20 of 4 using the reciprocal rule. And notice how we switched the base and the argument. And we can also rewrite 1 over log base 5 of 20 as log base 20 of 5. So now the two logarithms have the same base of 20, so we can use the property log base a of b plus log base a of c equals log base a of b times c, and rewrite this as log base 20 of 4 times 5, and since 4 times 5 equals 20, this just equals log base 20 of 20, which is just equal to 1. So the arguments, both being 20, in the original expression meant that when we applied the reciprocal rule, the two resulting logarithms would have the same base instead, since when we apply the reciprocal rule, we reverse the base and argument. And that allows us to combine the two logarithms into a single logarithm, which simplifies nicely. So here's another example. Let's say we have log base 2 of 5 times 1 over log base 8 of 5. We can rewrite the second term using the reciprocal rule, and this just becomes log base 2 of 5 times log base 5 of 8. So basically, we got rid of the fraction and brought the logarithm in the second term into the numerator, and we switched the base and the argument. So we can use the change of base rule to rewrite log base 2 of 5 as log of 5 over log of 2, and rewrite log base 5 of 8 as log of 8 over log of 5. The log of 5 in the numerator and the log of 5 in the denominator cancels out, and this just becomes log of 8 over log of 2, and we can use the change of base rule again, but in the other direction, to rewrite this as log base 2 of 8, and that's just equal to 3. So this entire expression is just equal to 3, since 2 to the power of 3 is equal to 8, so log base 2 of 8 is equal to 3. Of course, there are other ways of doing this, but this is one way. We could have used the change of base rule from the get-go, but that would have involved a complex fraction.